remember, so we're staying with 154. I'm just going to show you real quick towards the beginning on 144. I told you that when we're thinking probability, there are two major branches, right? Theoretical is what should happen. Experimental is based on what actually happened. Okay, so we spent a little bit of time on this camp. Now we're going to go over to this camp for a bit. But you could be asked to answer for both, where there's a mix between something that was experimented with and the theoretical. And the sample size is the determining factor of why they're not the same. Okay, so let's go to 154, and I will just ask you to add a few words there and highlight. If you have a highlighter, this is the time. Okay. All right. So theoretical probability, I will add it right here at the top. Not based on data, right? Or trials. Okay. Theoretical probability mostly dealing with games, right? So what kind of games? Card games, right? So cards, dice, spinners. It's like the spinning wheel, right? Things like that. Not just, but mostly dealing with games such as card games, dice, and spinners for the most part. Okay. So this is big here. This is a note not based on trials, right? In the previous section, so this is where I'm going to grab my highlighter. Previous section, you calculated probability based on data from samples or trials. There's another type of probability. It's called the theoretical probability. I'm going to highlight that there. Okay. It is based on, okay, an event occurring based on the number of possible occurrences rather than the number of items or trial. Okay. And then it gives you an example of theoretical, which is the coin, right? There's a 50-50 chance that it will land on heads or tails, right? So that's theory. It's based on there's one option out of two, right? Now compare to this problem, right? We're just gonna say here, theoretical and experimental probability may differ if the experimental sample size is smaller, right? A large sample, the experimental probability should be close to the theoretical probability. Okay, that is very important right there. Okay, so watch for this, like sample size. That I would on the side just make a big note like this talks about sample size, because that will come up quite often. So basically, how would you get a larger sample? In a nutshell, is performing. What happened there? Performing more trials. Or experiments. that's how you would increase the sample size. And also you need to look at various other factors, but sample size for the most part is the problem, okay? So now, before we're going to start with a deck of cards. Before I do that, I want you to take your deck of cards handout and talk about it a little bit. You're not going to be able to, listen carefully, you're not going to be able to use this handout for a test, but it will help you to kind of put stuff on your study sheet that is extremely important to have. So let me just zoom out here and I will ask you to maybe just highlight a few things. Let me just see here. It's hard to see, but you have the handout, right? The first thing you need to know, and I'm assuming most of you know your deck of cards, but not everybody does. Okay, so let's just hang in there and let's make sure we're all on the same page before we jump into this. A standard deck of cards does not include jokers. So there are no jokers, don't worry about them. There are 4 suits: diamonds, hearts, spades, and clubs. And every suit has 13 cards, giving you a total of 52 cards. Okay? Add to that half of the deck would be black cards, which is 26, and the other half, which would be the red cards, would be also 26, right? So clubs and spades are black. So these are your black cards, 26, and then you have 26 red cards, right? Because hearts and diamonds, each 13, give you the 26. I hope that makes sense. Add to that, it's hard to see here. You should look where my pencil is down here. I'm letting you know that these cards here, every suit has 3 face cards: Jack, Queen, and King. They have a face on it. So you have 12 face cards. It's very important to know because quite often I will ask you, hey, what's the probability of drawing a face card? And this keeps coming back, so please make sure you have this on your study sheet. I will give you a bit of a trick for your study sheet. That's courtesy of me, right? And then at the end here, I need you to know that with the face cards, if there are 12, half of them, 6, right? 6 black faces, and there are 6 red faces. So they can be split up further into their colors, right? And keep that in mind. Also, there are 4 kings, 4 queens, 4 jacks, 4 of everything, right? So if you look at it this way, like how many aces are there? Oh, I don't have that on here, but these are aces. Number 1, right? The 1 card, those are called, we refer to them as aces, right? So 4 aces, 4 twos, 4 threes, and there's 4 of everything on a deck of cards, okay? There are only, may I add, 2 red 4s, right? Or 2 black 4s, but if you don't care about the color, there's 4 of them, okay? Another thing that I want you to add is that if we're talking about number cards, there's 40 of them. So from ace all the way to 10, we count them as number cards. At least that's what we're going to do in this course, okay? So if I ask you what's the probability of grabbing a number card, oh, there's 40, right? 40 out of 52. A red number, 20, right? There's 20 red numbers, 20 black numbers, okay? So that is that. So here's the trick for your study sheet. Let me just help you out a little bit because you don't have that much room, right? You want to keep it for home finance. Home finance is the heavy hitter. You want to leave room for that. So let me just, maybe I will do it right on here. I think I can manage to do that somewhere at the bottom here. Okay. So it's like a tree diagram. There's 52 cards. Okay. Sorry, you can't see that. 52 cards. That branches off into 26 black and 26 red. And that branches off into that would be your clubs, and spades, and the reds would be your diamond and your heart. And you can actually just use the symbol for those, right? If you don't want to write it out. Diamond and heart are fairly easy to graph or to sketch, right? And so every single one of these has 13. This is the best I've got, guys. This is what I would put down on my study sheet, right? And every single one of these guys has 3 face cards. I like to put them like this, so you know that there's 12 in total, 12 face cards. So this is what I would say, hey, if you have nothing else on your study sheet, put that on there. Right? I hope that helps. It's the best I've got. If you have something better, let me know, okay? I want to hear from you. I'm sure there's something better out there, especially grade 12 students. They're very smart by the time they get to grade 12. Okay, so this is what if you can add that to your study sheet by tomorrow, you'll be in good shape. Obviously, this doesn't cover everything. Like, you need to know that there's 4 fours, 4 aces, 4 queens, 4, right? Like, those things are just, I hope you will understand that part. I'm thinking here. It would be, technically, you always have ace, and you have 2 to 10, and then you have your jack, queen, king. How's that? Almost looks like a secret code or something. But ace, 2 to 10, jack, queen, king. Every single suit has those. So maybe that'll help you out. That Q doesn't look like a Q, does it? There you go. So how would you use this? Red face cards. Like, how many red faces are there? You just go, okay, red goes into this and this. There are obviously 6, right? Because this is these 2 here are under red, right? So there are 6 red face cards. There are 6 black face cards, and so forth. How many spades, like a spade face card, is there? That's very specific. There are only 3, right? And so just keep that in mind. So now we can get started. Go back to the booklet on page 154, and we will come up with the probabilities of the following, of randomly drawing each of the following cards. Break this up into columns like that. And I will add to this, so make sure you add that, because this doesn't cover nearly enough, in my opinion. So, probability, right, of drawing a heart, you would just say, well, I know that a deck, we're talking about a standard deck of 52 playing cards. There are 52 total. How many hearts do we have? 13, that's right. There are 13 hearts. That's it. Just leave it like that. You're good to go. That probably isn't that difficult. So 13 divided by 52. Oh, look at that. It's 0.25. So you write 0.25 and 25%, right? So we have our 3 ways of stating that answer. Let's do that right underneath here, if you could. Right underneath A, B, C, D. This would be D. Not a heart. What would be the probability of not drawing a heart? This is how you need to do a little bit of indirect reasoning. So what you do is you take the 52, you subtract the hearts from it, right? Look at that. Right? 52 minus all the hearts that you have, and that would give you 39, right? You've got 39 cards that would not be considered hearts. So the probability of drawing a card that is not a heart would be 39 over 52. 39 divided by 52, watch this, is 75%. And remember, I always told you that the probability of something happening and not happening always adds up to 100%, right? So there you have it. The probability of randomly drawing a blackjack, right? So you still have 52 cards in total. How many blackjacks do we have? This is where I need you to wake up. 2, right? Would you agree that there's 2? Some of you are probably like, I don't know. There are 4 jacks in total. Only 2 of them are black, right? So 2 out of 52. You're going to have to wake up because soon you're going to have to do this on your own. 2 out of 52. That is 0 point, watch this, 0.4 decimals, right, if you need to. 8, what does that 4 turn into? Turns into a 5, right, because this 6 bumps that into a 5. You multiply that by 100, and you get 3.85%. Drawing a card other than a diamond. This is really saying not a diamond. Yes. It just turns out that way, yeah, with this scenario. So not a diamond, I take 52. I subtract the diamonds from it over 52. And that's 39 over 52, which we already know is 0.75 over 75%. Yeah. So not, if it says not it, take it away from the total to get that. That's the quickest way of doing it. Okay. And we're going to do 2 more, maybe 3 on the back side of this. So flip over to 155. And we're going to cross these out because these weren't supposed to be there. So just cross out this one. I will tell you I want you the probability of drawing a red face. Okay. So cross out B and just replace that with drawing a red face. So figuring out the probability of drawing a red face. And C, probability, watch this, of drawing a card, drawing a, let's do 5 or a 7. 5 or a 7. Probability of drawing a 5 or a 7. So I want you to right now take the risk, 0 risk. Can you answer both of them on your own right now? Put down a number out of 52, turn it into a decimal and a percent as well. Answer both of them on your own. Just take a few moments. I'll pause it here for a bit. So try those. I'm back. A red face. It's out of 52, no doubt, right? A red face. I'm going to look over here. I'm going down red, and there's 3 and 3, so there's 6 face cards, red face cards. Okay, and that would turn out to be 6 out of 52. That's 0.1154 times 100 is 11.54%. So about a 1 in 10 chance, right, to get that. Next, probability of drawing a 5 or a 7. So watch this. How many 5s do you have? Right, you have 4 of them. Sorry, you have 4 5s and 4 7s. So when it says or, you need to add them up. So I will actually do 4 plus 4, which is 8 out of 52. So then it's 8 divided by 52. That's 0.1538, which is 15.38%. Next, a red number. I will skip that part, the part where I show you the diagram. There are 40 number cards. Half of them are red. So this will be 20 out of 52, which as a decimal gives you 0.3846, which in turn gives you 38.46% if you multiply that by 100. Can I show you something next here? If E says not a red number, what's the probability of you not getting a red number? Watch carefully here. Yeah, so how much did you say? 32. Right. Yeah, I had to think a little bit on that one. I wanted to show you a different way. Okay, can I do that? Are you ready for this? 100% minus, can I use this? Whoa, right? You're probably like, I can't believe this. But I'm taking away, if 100% is all the cards, I'm taking away the red numbered cards. So 100 minus 38.46 is 61.54%. The only thing is you didn't state it as a fraction. Big deal. If I don't ask you specifically, don't worry about it. Okay? You could have done decimal, 1 minus this, and state it as a decimal. That's fine too, if I didn't specify. So all the cards minus the one that are red face, is a red number, gives you that. Okay, so, and it is 32 out of 52. That's correct. All right, now let's do the one spinner, and then I'll send you off on your own. Okay. Classic. What's the probability of the spinner stopping on a star? So you just go 1, 2, 3 stars. So that'll be 3 out of, there's 10, right? If you count all of them, it's 10, which is 0.3, which is 30%. Let me just say this. Sometimes you'll have a spinner, and right next to it you'll have, and John, right? John actually spun this 200 times and got the following results. you'd be like, wait a minute, like there's a spinner and there's a table, like what's going on here? That's when you're gonna start seeing like this is a theoretical. In theory, this is what should be happening. And then you'll have another one right next to it. This is what actually happened, right? And sometimes I'll ask you to see are they close? Are they close or not? If not, then you need to probably spin more times because this is what should be happening in the long run. Okay. All right. Now I want you to go to the workbook. All right, and you open it to page 2. You have a chart like this. You should be able to finish this today. Okay, I'm not asking too much here. And tomorrow we will do dice. Okay. In your workbook, you'll have like the probability of drawing the following cards. I'm asking you to fill in fraction, decimal, percent. Now, to make sure you understand this, I want you to first do the fraction only, okay? Just focus on filling in the fractions for every single case. Time allowing, we will do decimal and percent after. That's not as important to me as you figuring out what would that fraction be that needs to go in there. But, hold on. There are two cells at the bottom that I want you to add. Because there's not enough not in there. Okay, there's not enough not. Get it? So just add not drawing a red 5 and not drawing a red face. So just at the bottom of that table on page 2. And as you're working, I will bring up the answer key, and not right away, but as you're working through it. So before you do anything else, you want to try this. Okay.